Okay, we come to the very last section of our factoring polynomials, 7-6, choosing a factoring method. We have done several sections. We have learned 6, 7, 8 different ways to factor polynomials. Clearly, this is why I told you it was the most difficult section of the entire textbook. Factoring polynomials is not something you learn in one day, 1 week, or one video. It requires a lot of time for you to put in and for you to practice and make sure that you understand what's happening. So let's take a look at just a summary, and then you need to go back and you need to look through the worksheets and you need to study it. 7-6, choosing a factoring method. Step 1. First thing you're going to do is check for a greatest common factor. You're going to check for a pattern that fits the difference of two squares or a perfect square trinomial. If you can see that pattern right away, you could be done. You don't need to go through all of the long ways if you see the shortcut right at the beginning. If you factor a trinomial, x squared plus bx plus c, you are looking for two numbers whose sum is b, but whose product is c. If you have a coefficient in front of that x and all of a sudden you have a quadratic trinomial, ax squared plus bx plus c, you have to check the factors of a and the factors of c in the binomial factors. The sum of the products of the outer and the inner terms should be b. This is where we learned what we called Daniel's method. So if you're not familiar with my class, you need to go back and look at all of our other videos to understand Daniel's method. Number 4, you have to check again for common factors, because even when you're done, if you still have a common factor, you have to pull it out. Methods again. Any polynomial, you look for the greatest common factor. AB minus AC, A is a factor of both terms. In binomials, you look for the difference of two squares. If these are perfect squares and it's subtraction, I have difference of two squares. In trinomials, you're going to look for a perfect square trinomial. So you're going to go back to 7-5, and when you see that the first and last term are perfect squares, and that if you multiply the roots times 2, you get the b value, you have to go back and look at all of that. It's not going to just come to you. I show you here where you can either have a plus b squared or a minus b squared. This was all determined by the middle value, the negative 2ab or plus 2ab. What I'd like to do now is go back and do a little bit of summary from each section. I'm not going to reteach it to you. I'm only going to refresh your memory and ask that you go back to each section and look at it again. In 7-2, we saw a basic binomial, and we have a common factor. We pulled the x out, and we're done. We have a trinomial. We have a common factor. We pull the 5y out, and we're done. We have no more factoring that we can do with the inside. Those were easy, 7-2. Here we saw that we have 7 times x minus 3 minus 2x times x minus 3. That x minus 3 is consistent. It becomes its own binomial. It is the greatest common binomial. You pull it out, and then you take your 7 minus 2x for your second binomial. I've left you some examples here for you to look at, refresh your memory. Factor by grouping. This is where you usually have 4 terms. If you have 4 terms, you try to group them into groups of 2 terms that have a common factor. So I take my 12a cubed, 9a squared, I pull out the 3a squared. Here I pull out the 5. I have a common binomial. So I refactor it with a 3a squared plus 5, and I use the 4a minus 3. Clearly, again, this takes a lot of thought, and you must keep looking for common factors at every step. Just because you do one level doesn't mean you're done. You have to keep going till there's nothing left to factor out. Factoring with opposites. And this was really difficult section. Again, I need you to go back to it. You can inverse the sign and the order, and you can have something that is equal. 2 times 5 minus x is the same as negative 2 times x minus 5. Complicated. Again, I'm not teaching it to you. I'm just showing you to refresh your memory. Here, we ended up with almost a common binomial. X minus 5, 5 minus x, but so close but not the same. But I can create x minus 5 by making that 2 negative. Now I have a common binomial. Factoring trinomials. Now there's a whole bunch of these. When C is positive, C is negative, B is positive, B is negative. X squared has a coefficient, X squared doesn't have a coefficient. We have a lot to review. When C is positive, again, you are looking for factors of 8 whose sum equals 6. What happens if C is negative? You still need factors of C whose sum equals 7, B, but because this is negative, we know that we're going to have one positive and one negative, and we're going to know that the largest digit needs to be positive so that I get that positive 7. We have Daniel's method if we go to ax squared plus bx, so now my x has a coefficient. Now it's a little more difficult. A times C, and I get a 24. Factors of 24 that equal B. And I will get my 2 factors, my binomials. I bring down A, I bring down C. I am only looking for the 2 middle factors, which are right here, 8 and 3x. If B is negative, that's okay. If B is negative, then that means that my factors need to be negative. 2 negatives multiplied together make a positive, but when added together, stay negative. Now I have a negative C. I can have a negative C, which means I have to have a positive and a negative. But because B is positive, my largest absolute value digit has to be positive. If B is negative, my largest absolute value factor here has to be negative. What happens if my A coefficient is negative? Well, I can do something very simple and just pull the negative 1 out right now and change every term to its inverse, and then factor the same way we already know how. We end up with 3 sets of terms. So I have a very long polynomial. I have 3 this time instead of just 2 binomials. I have still polynomials. Factoring special products, which we just did in our last slide, I can have a perfect square trinomial where A and C are perfect squares, and when you multiply the roots times 2, you get B. I also can have difference of 2 squares. Here I just have a binomial with a subtraction sign, but if A and B are perfect squares, then I can have what's called the difference of 2 squares, where I end up with an A plus B and an A minus B, or 2x plus 3, 2x minus 3. You want to be careful. Make sure you remember all of your rules for exponents, because that's a huge part of polynomials. Good luck. Please go back over all of the other slides before you think that you can take a test on Chapter 7. And just for the sake of getting into Algebra 1 and being successful in Algebra 1, you need to understand polynomials. Enjoy.